Welcome to Heavens Declare. I'm Jim Burr, and today we are talking about the solar system. We left off last program talking about our Earth and the planets, and we're going to continue on with that. But the heavens declare, yes, they sure do declare the glory of God, don't they? We see the beautiful. This Hubble is just fantastic. What the Hubble has shown us that we've never seen before, and so our first graphic is going to be of Saturn. You know, the rings of Saturn are incredibly beautiful. Can you imagine waking up in the morning and seeing a sunrise? These rings would go up 50,000 miles. Can you imagine a sunrise rippling through rings for 50,000 miles, or a sunset rippling through space? I'd like to show you that picture now, that graphic now, of a beautiful picture of Saturn. And this is one from the Hubble Space Telescope. Those rings about 170,000 miles across. Saturn about 1 billion miles away from us. And that roll now of the eruption on the sun, and tremendous eruptions on the sun. But headed off to the side of the sun rather than headed directly at us, because these eruptions headed our way could cause serious problems on Earth. Back in the 1800s, we had a solar flare that actually melted down telegraph lines. In 1986, I think it was, in Quebec, a solar flare melted power grid down. And we haven't had any really big ones headed our way. There was one headed to Mars here a while back. I've just invented a binocular telescope. This is a telescope, you get one for each eye. And you actually look down, and it's looking behind you. We have handlebars. You see the handlebars there. It's kind of a cross between a Harley and a telescope. So you look down into it, and when you can use both eyes, it's a whole different world. It is unbelievable. And these are some of the other ones, a 6-inch, the middle one's a 10-inch, and then a 16-inch. And then here's a really big one on a trailer. And then a few pictures for the kids. Did you ever look at the sky and see a cloud looks like a teddy bear? Or maybe a bunny rabbit or a big bird. And but when we look through a telescope, we see things that look like ants. This is called the Ant Nebula. And it's interesting because the biggest stars seem like a balloon to burn up their fuel and get bigger and bigger and bigger. And then, like a balloon, they sometimes pop, and we call that a supernova. And when that happens, these things shoot out smoke rings. Here would be one that would send out smoke rings. I mean, these rings go out at hundreds of thousands of miles an hour. And this little illustration really shows you what happens when we have an exploding star. You see how those rings just change. And when we look through a telescope or take a picture, we get these beautiful rings that are constantly expanding and changing as that gas goes out. Now, some of them shoot out jets, and that's the first one we had here. The Ant Nebula probably has a very intense magnetic field that directs the gas outward, and so these jets shoot out like this little thing, you know. But here's the Guitar Nebula, and here's a heart on Mars. And we've got two, because we've got a double meteor impact on Mars. It looks like a heart. Quite a beautiful sight. And we even have a happy face on Mars. And North America, we have one area. In fact, this is dead over us tonight. The North America Nebula, very large. And you know what? It looks just like, a lot like North America. You can see Mexico and Florida. You can see Minneapolis, Lake Superior, Hudson Bay, New York, and so forth. Kind of fun looking at that cloudy area, gaseous area, and it kind of reminds you of the constellation, North America. And North America. And this is in Orion. This is the Horsehead Nebula. This thing is huge. This is so big that you could put 100 of our suns right across the bridle of that horse snout with all the planets. 100 of our solar system would fit right across there.
100 suns would fit right across. That's a huge, huge area in Orion. And here's, to go along with that, a little seahorse. And the reason I put this on, God's beautiful creation, but somebody also has here's another seahorse. He's got the fins and the snorkel and everything. Okay, just a little fun there. This is a beautiful sight in our Milky Way galaxy. We don't even know what this is. They don't believe it's an exploding star. The top picture was taken, well, actually, this started in 2002. We saw a big thing getting brighter and brighter and brighter. And the Hubble had assignments until May. The Hubble could not get a picture. We saw it first in January, but in May they got the first Hubble picture. And then the bottom picture is actually how it has changed from 2004. They don't think it's an exploding star, but it's a burst of light that's just glorious. And here you see how the size of our Earth compared to the Sun. 1 million Earths would fit in the Sun. And our Sun is just kind of an average star, nothing special, just kind of a ho-hum average star. And it's 93 million miles away, and we just get a little sliver. The heat that thing radiates, we're 93 million miles away. We just get a little tiny sliver. That sun cranks out enough energy to run 10 billion Earths and heat them hotter than you'd like to heat them. Okay, somebody showed us how big, if we put 1 million Earths inside of a globe, that's what Earth would look inside the sun. So you see, we're pretty small. We're basically an atom on an atom. Now, this is the biggest sun we know about, the biggest star. It's Canis Majoris, 1.8 billion miles in diameter. Look at our sun compared to that, where the arrow is. That's our sun compared to Canis Majoris. This is the big. As we move along, here is a comet hitting our sun, and the sun would be right behind that little white circle there. But look at this eruption, about 10 million miles of gas blasting off the sun. That comet, which is basically a big ice cube, the circle, the sun, is less than 1 million miles in diameter, slightly less than 900,000 miles in diameter. The comet probably did not go straight through that sun. It just grazed the top or the bottom. I don't think a comet could cause that kind of a thing going right through the middle of the sun, given the temperature of the sun. Well, where do we live? Okay, this is kind of what we think the Milky Way galaxy is. Excuse me. This picture was taken with the Cassini spacecraft, and the sun is right behind Saturn. I showed the position of the sun. You see the sun rays, you see the sunbeams there on the picture, I'm sure. And so the sun is behind Saturn. Cassini is going around Saturn. Venus going around. We got Earth going around. Look at here. Here's Earth. Can you see the dot? That is Earth from 1 billion miles away, and you're on it. Can you see it on the screen? Or is it too small? It's right in front of the arrow is Earth from 1 billion miles away. Oh, yeah, it's there. I can see it. When I see that picture, you know what I think? Satan went to tempt Jesus. He says, if you fall down and worship me, I'm going to give you all of that. I don't think Jesus was impressed. Because the Bible says all power is given to him in heaven and earth. We're going to move on. My wife and I were doing camp meeting in Australia, and I have a special telescope. We've been looking at the sun for years. We can see eruptions on the sun. This was the picture what we saw in Australia, 2008, I think it was. The biggest eruption on the sun I've ever seen. Incredible eruption. That's over 100,000 miles that went up. Just a breathtaking sight to see. This is the Omega star cluster, the Hubble zooming in, and when it switches to color, now you're going to see the new color camera, $125 million camera, but it's going to show you how these stars are going to move in the next 10,000 years. It plotted those for 4 years. And here is how they're going over the next 10,000 years. Now, they're not just on a wall. They're going in 3 dimensions in every different direction. And they're taking planets with them. And the interesting thing is, Jupiter moves our sun 500,000 miles, 500,000 miles. When Jupiter goes around our sun, it moves the sun off center,
500,000 miles.
Wow.
When your kids are little, you swing them in a circle, you know, but when they get bigger, pretty soon they're swinging you, right?
Okay.
Well, Jupiter swings it off 500,000 miles. And what is interesting, I attended a lecture on gravity from the University of Oklahoma, and this professor said that when you have three, Jupiter, we got two, Jupiter and the moon. When you got three bodies of different sizes, there's no mathematician on Earth that can give you a formula for the center of those three. It can't be done. And when I got back home, I emailed him. I said, Professor, before I repeat that in public, did I hear you correctly? I got choked up when he said that, because I've been showing audiences these stars going, and I realized we got 100 billion
Wow.
in our Milky Way galaxy, and God got it all figured out, and we can't figure out three. He said yes. He said, Google three-body problem. Since Isaac Newton, for 330 years, we have not been able to come for a formula, give you the center of rotation. Now, he said, we can get close, we can simulate it on a computer, but there's nobody been able to write a formula for the exact center of rotation of three. Now, what's incredible, we have another clip coming up in just a little bit, and it's going to show you how our sun is going. 45,000 miles an hour. I mean, we've got so many different motions, taking the planets with it. And so here you see all the planets going around the sun. That outer one there is probably Pluto. It takes Pluto 247 years for Pluto to go around the sun. It's traveling at 10,600 miles an hour. But you can see Saturn and Jupiter there orbiting the sun, traveling through space. So when you think of that other previous clip where we had all of these stars going in different directions, realize they're all doing this probably with planets in every different directions. What a God we serve. Planets in every different directions. What a God we serve. What a God.
That's
We can't figure out
mind-boggling.
three. What if we had to try to figure out four?